Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, this one question lost more marks than any other on last year's paper, and it wasn't because the maths was hard. Students simply forgot to read the units. If you miss the units, you can do every calculation correctly and still lose the final mark. Sound familiar? Let that sink in.
Ouch! That hurts. So today we're focusing on gradients, what they actually mean and how to avoid that mistake.
Exactly. Section 1. The concept. We're only covering straight line graphs today. Gradients of curves are a separate topic. First, what is gradient? Plain English, gradient means how steep a line is. Mathematically, we write it as rise over run. Change in y divided by change in x. Simple fraction, big meaning. Example 1. Distance time. Imagine a distance time graph where the line passes through the points 0 hours, 0 kilometers, and 3 hours, 60 kilometers. To find the gradient, pick 2 points. Work out the change vertically and the change horizontally, then divide. So rise equals 60 minus 0, which is 60. Run equals 3 minus 0, which is 3. Gradient equals 60 divided by 3 equals 20.
Now, the important part, units. Our rise was in kilometers and our run was in hours, so the gradient is 20 kilometers per hour. That is the speed. If you just wrote 20, you'd miss the meaning, and an examiner will want the units. Write 20 kilometers per hour or 20 kilometers per hour. That's the interpretation. The object travels 20 kilometers every hour.
So, gradient isn't a number in isolation. It's a rate with units. Does the sign matter too? What if the line goes down?
Great question. Yes, the sign tells you direction. A positive gradient means the quantity on the y-axis increases as x increases. A negative gradient means it decreases. For example, a temperature cooling graph might have a gradient of minus 2 degrees centigrade per hour. Always say decreases at 2 degrees centigrade per hour, or rate of change is minus 2 degrees centigrade per hour, depending on wording. Be precise.
Let's do the second worked example, a price-quantity graph. Suppose the line passes through not units, £5, and 4 units, £13. Rise is 13 minus 5 equals 8. Run is 4 minus 0 equals 4. Gradient is 8 divided by 4 equals 2. Units are pounds per unit. So the gradient is £2 per item, the unit price. If a question asks, find the rate, you must say £2 per item.
What about when the line doesn't cross the axes at 0? Do we still do the same method? Yes, same method. Pick any 2 clear points on the line. You might use 1, 7 and 5, 15, for example. Always subtract y2 minus y1 and x2 minus x1. One common pupil slip is swapping rise and run. That gives the reciprocal and costs marks. Rise over run, not run over rise. Write it down so you don't forget.
Section 2. Exam technique and the quick win. What do examiners want to see on a gradient question? Typically, this is a 2 to 3 mark question. The usual split is M1 for a correct method, showing rise and run and doing the division, and A1 for the correct answer with units or interpretation. If the question asks state the gradient, you need the number and units. If it asks interpret the gradient, you need a sentence like the object travels 20 kilometers every hour.
Common lost mark steps. 1. Forgetting units. 2. Writing run/run instead of rise/run. 3. Choosing points inaccurately on a printed graph. And 4. Not stating what the gradient means in context. If you do 2 clear steps, show rise and run, and then the division, you capture the M1, even if there's a small arithmetic slip.
Write the method, not just the number. The examiner wants to see your method.
OK, you promised a quick win. What's the two-step check you can use in the exam?
Quick win, a 10-second two-step check. Step 1, label the units next to your final number. Step 2, substitute one of your chosen points back into the implied rate equation to confirm. For a gradient m, check the equation y equals mx plus c with your point. If it fits roughly, your gradient is consistent. This catches mistakes where students accidentally swapped the difference. Memory aid, label, then plug. Don't skip the check.
Label, then plug. Love it. Quick and usable under time pressure. Section 3. Practice challenge. Try this one now during revision. A straight line goes through 2 hours, 30 kilometers, and 5 hours, 75 kilometers on a distance time graph. Find the gradient and interpret it. Write down your method to pick up the marks. Hints: subtract the y values, subtract the x values, divide, add units, then interpret in words.
Hints continue. For method marks, you could write rise equals 75 minus 30 equals 45, run equals 5 minus 2 equals 3, gradient equals 45 divided by 3 equals 15 kilometers per hour, and then interpretation, the object travels 15 kilometers every hour. Even if arithmetic is off, the examiner sees the method.
Final quick recap and resources. That's your core idea: rise over run, always include units, and label then plug before you move on. If this helped, share it with a friend who's revising. You'll find more worked solutions and downloadable practice sheets at workbook.jcacademyonline.co.uk. That's your quick win for today. Stay curious.